Hello friends, I'm Ajitav Basab. Welcome to another episode of Automation Digest. I've come with another problem of DSA, which has been asked in multiple interviews. So let's straight away jump into the problem. All right, the problem is longest substring without repeating characters. Before I get started, let me tell you the solution that we are proposing is one of the best solutions on the internet. Okay, so let's go through the question. It's a medium type of question. We are given a string S. We have to find the length of the longest substring without repeating characters. We are given three examples. Let's take the first example. So ABC, BCA, CAB, all these substrings have the length 3, and that's the maximum substring that can be formed from the string to have no repeating characters. That's why the output is 3. In the second example, which has B repeated 5 times, always has the repeating character. That's why the output is 1. The length of non-repeating character substring can be formed by only one B. Similarly, for the third one, WKE or KEW, either of this has the length 3. The longest substring that can be formed with non-repeating characters in this case is also 3. Here in the constraints, it is said that S can be any English letters, digits, symbols, and spaces. And the length of string can be anything in between 0 to 5 into 10 to the power 4. Now, to answer this solution, we will be using an algorithm called sliding window. But before I get into the detail of sliding window, let me tell you what we would have done if it was a brute force approach and what is the demerit of it. So in the first example, we will take all the substrings possible in the string and find out which has the maximum non-repeating character and provide the result, which means we start from A, that being a substring, we go ahead and add B to it, then C, and that's it. Because A again will be a repeating character. So our first result would be ABC with the length as 3. Next, we start from B, we go to C, and then we go to A. So again, the output is 3. Now we start from C, that's 3 as well. Then we start from A, and that's 3 as well. Followed by BC, 2, CB, 2, and then only B, 1. Now, while we were creating the substrings, we actually repeated multiple steps which were already done earlier, which means in the first attempt, when we already did create a substring of ABC, we knew that BC is non-repeating. For the next time when we started from B, we again did create a substring of BC which was earlier created as well, leading to decrease in efficiency. Same thing, when we started from C, we did a repetition of creating a substring CA. So think of this way. If there is a way where we do not need to create the substring already created earlier, it would become easier. It would reduce the time taken for the computation. So how do we do it? I think this is the right time I can talk about the algorithm. So sliding window, as the name suggests, it's all about creating a window and sliding it forward or backward. In this case, we select a window and identify the length till which the window can expand. And then we move the window ahead till we reach the end. And finally, we identify the length of longest substring. Remember, whenever there is a question related to substring, the first algorithm that we can think of applying is sliding window. Let's understand how to do it. For a sliding window, we always require 2 pointers. In this question, because it is an expanding window, we will start both of them from 0. In some of the situation, the pointers may start from different locations. Let's say we have 2 pointers, left and right. We also require one additional variable to calculate the length of the substring. We will assign this to 0 at the beginning. Now, we start with the first element. Is this unique? Definitely. The first element is always going to be unique. Now, because it is unique, my substring is of length 1. So, longest also becomes 1. Now my right moves to the next element B, and the substring now is A, B. Are both the elements unique? Yes, they are. So my longest again gets incremented to 2. Remember, there is no change done to left yet. Now my right moves to the next element C. Is this unique? Yes, it is unique as well. So my longest again it gets incremented to 3. No change to left is done yet. My right now moves to the next element. It encounters A. A had already been encountered earlier. Because it had already encountered A, my left quickly moves to the next element. After my left moves to the next element, we again calculate the length of substring. In this case, the substring BCA has the length 3, which is equal to the already present longest. So no update to longest is done yet. Right moves to the next one. B, it has already encountered B earlier. My left moves to the next element, which is C. CAB is a substring which has all unique characters. Length is 3, equal to longest. No update to longest is done yet. Right moves to C. Again a repeating character. Left moves to A. No update to longest is done because the length again is 3, A, B, C. Right moves to the next element, which is B. It had encountered B earlier. But remember, B was encountered here. B has been encountered here. We are not going to consider the previous one. We are going to consider the latest B. Now my left is at A. The next element is B, which is a duplicate element. So my left pointer doesn't move only one step. It jumps to C. So what did we understand from this? Whenever we encounter a repeating character, we skip that character and move one step ahead of it. So in this case, my substring becomes CB, which has a length of 2, lesser than what longest is. So no update is done to my longest. Same way, it goes to the next element, which is again a B. Now this is a repeating character. We encountered B in the previous element or iteration itself. So my left again moves ahead to the current element itself because it is not supposed to consider the previous element as well. Now the length of my substring is 1, which is smaller than longest. We are not going to consider it as well. Finally, the iteration is over. So I return the length of the longest substring as 3. All right. Let's do this in code. So let's take the variables already talked about first. Now we have to keep a track of the elements or characters encountered. How do we do that? We can create one array of length 128, which is the length for ASCII table having the characters. The extended ASCII table is of 255, but the elements which we would be using here would be present within that 128. So whenever we encountered such character, we can place the index of the character in the string. We can place the index in our array. All right, let's have our for loop. The initialization of left and right was already done. So we are not going to initialize anything in for loop again. We traverse till my right reaches the end of string. Now, if you remember in the example, whenever we encountered a repeating character, we moved our left pointer to the next element of the repeating character. And in our program, we used an array to store all the values of index wherever any repeating character is encountered. So we have to update the array based on the values where we encountered any character. But this cannot be done at the beginning itself. It has to be done after we identify the left used for my substring calculation. And my left will keep moving based on the value present in the array. So here I am assigning left to the maximum of the array index, which has the updated index for the character and the left itself. This way, my pointer moves to the position where no repeating character is present. Now, the last step of the program is to calculate the length of the longest substring. This is my longest, the maximum of the previous longest and the length of the current substring. And we are done. We just now have to return the longest. If I run this code, all my test cases pass. And if I submit the code, we get a runtime of 2 milliseconds, which beats 100% of the solution, and a memory utilization of 42.2 MB, which beats 95.89% solution. That's all for today. Hope you like the solution and the video. I'll be back to Automation Digest with some more interesting facts. Till then, happy coding.